Learning objectives for this segment, we're going to understand whether a solution is a weak, strong, or non-electrolyte. It's a very important division in what happens when a substance is dissolved in water, and be able to identify spectator ions in a reaction, determine the net and net ionic equations, the ionic and the net ionic equations in a solution reaction given the molecular equation. Review what that means in a little bit. Okay, there's three main types of behaviors when things are dissolved in water. What could happen is that a compound breaks completely apart. It's an ionic compound, and in water it completely dissolves into the component ions. There is none of the original crystal left, it's all in ions. What you get there is a liquid that conducts electricity, because as the ions move, that carries an electric current. And so that's what's called a strong electrolyte. You can actually run a current through an aqueous solution that has all of the ions dissolved. So that's one common type. The other common type is a non-electrolyte. Something like ethanol, which doesn't actually, the covalent bonds don't break apart when they're in solution. So that does not conduct electricity because there's essentially no ions around. The ions carry the charge. They're what conducts the electricity between, you see in here, between these two electrodes here. The only way that you can get electrical current to go back and forth between there, because you can't pass electrons by themselves, is for the ions to flow. So if there's no ions, because something like ethanol doesn't actually break apart into ions, it's a non-electrolyte. So strong electrolyte, everything breaks up. It's something like an ionic compound that completely breaks up into component ions. There's lots of ions to conduct electricity. But there are a lot of cases that are in between, that are weak electrolytes. For example, acetic acid, talk about a lot more acids and bases in later segments than later in the course, breaks apart a little bit, like maybe 1 or 2% of the molecules break apart. In this case, an H plus an H plus ion comes off, leaving an acetate ion. And so there are some ions in the solution if you're just sitting it around at room temperature. And so it weakly conducts electricity. This is a weak electrolyte. So those are the three main types of behaviors that compounds undergo when you stick them in water. And depending on which of these happen, you can get very different types of reactions. Okay, so let's just test this for a second. So 3 different ionic substances with the molecular formulas A2X, A2Y, and A2Z were dissolved in water with the following results. Which of the substances is the strongest electrolyte? And here, the water molecules are not shown. They're just sort of the blue background. And A is always green. So I'll pause for a second so you can think about which of the following compounds is the strongest electrolyte. Pause and try to answer it yourself. All right, so the strongest electrolyte will be the one that entirely breaks apart into component ions. And clearly in this case, A2Y has completely broken apart. If there's the most ions in the solution, it will be the best at conducting electricity. So that's the strong electrolyte. The others are weak electrolytes. They're not non-electrolytes because they break apart to some extent. AZ is sort of in the middle. It's an A2Z, and this is the weakest one right there because only a small fraction have broken up. But they're all, A and C are weak electrolytes. B is the strong electrolyte.